Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. Coming up next, we're going to learn how to build game actions with blueprints. But first we need to know, what is a blueprint in the Unreal Engine? Blueprints are a visual scripting language. They allow you to give behavior to your objects. For example, you can make a player move in a certain way, or you could increase the player's score when they touch food or when they attack another player. You could reduce the player's health. You could write an object like a coin and give it a behavior of being able to spin, or give that coin a property as well. You could give it a property of having the value of 2. So anyone who touches that coin will increase their score by 2. So you can give behavior and also properties to objects with blueprints. In Unreal, you can either write this behavior of your game, otherwise known as functionality. You can write this in either blueprints or in C++. Now, both are drawing upon the same concepts of programming, because blueprints do use variables, functions, loops, classes, these concepts from programming. But blueprints allow you to write your functionality and properties a lot easier. It's a lot easier to build a blueprint and to debug a blueprint than it is to write C++ code, because C++ is a programming language, so you have to know programming, and also C++ is a more advanced programming language. But if you're working long-term in Unreal, it's definitely important to know how to do both blueprints and C++. But for a beginner, blueprints are the easiest way to write game functionality while still learning valuable programming topics. So should you choose blueprints or C++? Well, blueprints are easier for a beginner for sure. But over time, you may want to learn C++ as well, especially if you want to work long-term in Unreal. With blueprints, usually blueprints have an object that you can see in the world. So a blueprint will not just be a script of what something should do and the properties of something, but usually a blueprint will also have a visual component. Like you'll have a light and you'll have an actual physical coin that is a 3D coin in your game. Or it'll be an actual player, or it will be a weapon. Usually a blueprint will have a visual component, but not always. A blueprint could be purely a script, like a game controller. You can then attach behavior and also properties to the blueprint. If an object doesn't need a behavior, it often doesn't need a blueprint. For example, if you just have a tree for your landscape or a tree for decoration in the game, it doesn't need to be a blueprint, it can just be an object. But if you wanted that tree to have a power or a property or a behavior, then you could write those in a blueprint. A blueprint is like a class, if you're familiar with object-oriented programming. A class is an entity that describes the properties and functionalities of itself. So, for example, I could have a class called player, and this class will describe what are the player's properties and what can the player do. And a blueprint is just like a class. It's a replacement for a class in object-oriented programming. So blueprints are a great way to learn object-oriented programming in a visual manner, because blueprints, you'll see they use a lot of the same topics and data structures as does object-oriented programming. What can you do with a blueprint? Well, you write a blueprint and then you can actually use it multiple times. So I can create one blueprint called coin to represent a coin, and I can then have a visual aspect to the blueprint, which is one coin, but then I can put multiple instances of that coin throughout my level or throughout my world. So I can use the same blueprint but multiple times. And each of those coins is going to act independently. It still has common properties and common functionalities, but it acts independently. So blueprints are great because you can use replication. You don't have to write that coin over and over again. You just use a blueprint. Kind of like you're using a blueprint to build an airplane instead of building each airplane uniquely and individually. Each object will behave independently. So if one coin starts spinning earlier, the other coin can start spinning later. Or if my player grabs one of the coins, they won't be able to automatically grab another coin. The coins, they act independently. And that is an introduction to what is a blueprint. Coming up next, we're actually going to build out blueprints in Unreal, and so you'll get a better understanding of how they work. Blueprints can seem overwhelming at first, as can Unreal itself, because it's a huge engine, but just take it step by step, and with enough practice, you'll be understanding blueprints with ease, and you'll be writing blueprints without any trouble. It all just comes down to practice. All right, so join me in our next lecture. We're going to build out our first blueprint class. Hello, everyone, and welcome back to our course. In this lecture, we are going to learn how we can build a blueprint in Unreal. So join me in any Unreal project. All right, and here we are going to go into our content browser. So I'm just going to close my landscape, and I'm going to go to Window and open up my content browser 1. Here I can create a new blueprint, and to stay organized, I'm going to add a new folder just for my blueprints. Okay, and then I'm going to double click inside of the folder to enter it. Here I'm going to create a new blueprint class. So you can right click and select blueprints and add a blueprint class, or you can also use this add button to add a new blueprint class. Here, you'll then have several options of the type of blueprint you want to build. An actor, a pawn, a character, a player controller, a game mode, an actor component, or a scene component. And as well, there are actually many other classes of blueprints that you choose from. Okay, so you have a lot of options. Typically, you'll be working with the actor, the pawn, and the character. An actor is just an object that can be spawned in the world. A pawn is like an actor, except a pawn can actually be moved by the user because it can receive user input. A character, it's like a pawn, but it can also walk around. So they build on each other. Let's start by just creating an actor. So click on actor, and that will create a new blueprint with actor as the parent class. If something is a child of a parent, when you're talking about blueprints, it means that your blueprint can access different functions and properties of its parent. And it helps you build your game faster because you don't have to build every blueprint from scratch. You can actually use pre-built functionality and properties from Unreal. Okay, so that's why we made this an actor. Okay, I'm going to just drag out my window here. By default, it's called New Blueprint, and it's of type Blueprint class. But you can right-click and rename this. Just, let's see. Well, now I clicked on it to open it. But you can close that. Just right-click and select a rename here. And let's give this actor a new name. We'll call this actor_BP, which stands for blueprint. Then to open this blueprint, just double-click on it here. And this will open up a window with the blueprint editor. You can drag this around and put it anywhere you'd like. Okay, there we go. And here it is, actor_BP in a window. This is a data-only blueprint, which means I'm just looking at different properties of it right now. But if I want to add a script or variables, which means functions or properties to this blueprint actor, to this object, I can open the full blueprint editor. So just click on that and you'll be able to see the full blueprint editor for this actor. Okay, here we have several windows open. We have details, and this time this details is describing different components that you click on in your event graph. Okay, we can see all the components we have in our blueprint. Currently, we just have this default scene root, a default object. We also have the My Blueprint window, and this describes all of the contents of the blueprint, such as graphs like this event graph, okay, as well as functions which perform tasks, macros which also perform tasks, variables which store data in memory, and event dispatchers which perform events. You can also add more content to the blueprint just with this add button, where you can add variables, functions, and more. Okay, other than these three, we also have three more windows. We have the event graph. This is where you will write all of the functionality for your blueprint. You can also separate functionality into separate blueprints and then put them all together. You also have a viewport which shows you the contents of the blueprint, because a blueprint can have a geometry and material and objects. A whole scene could be a blueprint. We also have this construction script, and this is just the first default function that's created whenever you create a new blueprint. You'll always have this default function. Okay, and there we go. If we had some content in this function, we would see details about it in the details window. All right, so this is how you can create a new blueprint. Blueprints may seem overwhelming at first, but the more you work with them, the more you will be able to understand how they work and how to write functionality and properties of different objects that are reusable thanks to blueprints. And you'll find blueprints are a lot easier than using C++. Although there definitely are benefits to both. Okay, so now that we know how to build a blueprint and how to navigate the blueprint editor, join me coming up in our next lecture. We'll continue our look at blueprints and how to work with them. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to build a new blueprint and navigate the blueprint editor. In this lecture, we are going to learn how to add components to a blueprint. So open up your actor blueprint and click on the viewport window. This is where you can see all of the different visuals that are part of your blueprint, like a light or a cube or a 3D model or a particle effect or even sounds. All right, so any type of objects that are part of the blueprint. If you want to add new components to the blueprint, go to the Components window. Here you can press the Add button, and you can add components like you can add blueprint components, C++ components, audio, particle systems, lights, scenes, meshes, cubes, and more. Okay, there's quite a lot to choose from here. Okay, let's start off by adding a static mesh to our blueprint. And then hit enter. Okay, you'll notice here the compile button has changed to be yellow, which means it has to be recompiled. Anytime you make a change, you have to compile and save your blueprint if you want it to actually have effect in the world. But also, if you do hit play, Unreal will also compile all your blueprints for you. Okay, so here we've added a static mesh, but you may be wondering, I don't see any geometry in my viewport. The reason being that a static mesh is by default empty. So you have to go into the details window, and here, if you toggle all of these closed, go to the static mesh property. Here you can see it has the values none. But if you select this, you can change this to be some kind of shape, like for example, a cylinder. Okay, so now we have a cylinder inside of the game. Just zoom out in the viewport and you'll see it. By default, the objects are quite big. Okay, so here we now have a cylinder, and it's on top of this default object. Okay, it's considered a child of the default scene root. You could even move the mesh onto the default scene root if you don't want that default root, because it's really not required. It's just a placeholder. So now if you click on the cylinder, you can see all of its different properties. Like you could change its material, you could create a new material for it. Okay, you could give it some grime, for example. You also could set its components, its physics, its collisions, if you want to enable colliding with this object, not being able to go through it. Okay, you can set those. You can set lighting, rendering, navigation, virtual texture, tags. There's quite a few different properties here, as well as events, which refer to what you want to happen when the object collides with something or has some event happen to it. You can also add a collider to this object just by searching here for collider and then choosing a collision type such as a box. Okay, this will add a box collider to your scene. And you can take this collider and you can move it around. You can also reshape it just like you would any other object. A collider will process collisions because by default objects don't have collisions processed on them. Okay, you have to either add a collider or you could click on the object itself, and inside of collision you could enable collisions by enabling hit events and generating overlap events and changing the collision presets to trigger. Okay, so there are different options for being able to process collisions. Let's use a box collider in this case. So anything that collides with this box collider we can process. If you go into your level, any of the levels, you may be wondering, where is the actor? I don't see it in the game. The reason being that, sure, we did create the blueprint, but we didn't actually add it to the game. We just added it to our project folder. So if you want to add the blueprint to your game, you can just drag it right onto the game. Then you can press F to zoom in on it. Okay, so there it is. Now, a blueprint is reusable, so we could actually create multiple instances of the blueprint. You could drag it in a second time. So that is the benefit, one of the many benefits of using blueprints, is that you can reuse functionality. Instead of having to create each of these cylinders individually, we can just create one cylinder and then reuse them. So these cylinders, they could be food, they could be enemies, they could be players, they could be anything that we want to represent. And that is how we can build out a blueprint with some components. Okay, and we can add whatever components we want to be part of the blueprint. And that is how you build out your components. So now that we know how to add objects to a blueprint, join me coming up in our next lecture. We'll continue learning how we can use and work with blueprints. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to add components to a blueprint, and in this lecture, we're going to learn how to handle events with a blueprint. So join me back in our project and back in our actor blueprint. All right, here we are then going to open up our event graph. So click on the event graph window. Here we can see we have 3 event listeners already inside of the graph. We have event BeginPlay, and we can see that inside of my blueprint, it's listed as event BeginPlay. All right, you can double click on it in the My Blueprint window to zoom in on it. This is one default event. It's not required to have, you could delete it. It's just going to allow you to perform some action when the game begins, when you press play. You also by default have actor begin overlap. This event is going to fire when the actor of this blueprint overlaps with something else, so when it collides with something else, provided that those objects have collision enabled. You also finally have event tick. This node allows you to perform some action every tick of the game, otherwise known as every frame. So that is quite a lot of times. You want to be careful how much you put into event tick, just because it runs so often. If you have all of your game functionality in event tick, that could slow your game down just because this function is called so often. Okay, so these are 3 events. Okay, and events are slightly different from functions because an event is something that is like a listener. So I'm listening for when an event occurs. Whereas a function is something that is a task. It's a way to store a task and redo it over and over again. Okay, and now that we know these 3 default events, let's actually put one of them to use. Okay, let's start with event BeginPlay. Here we have this node, and we have the name event BeginPlay. We also have 2 little nodes that go off of this box. Okay, first we have the output delegate and the executable node. Let's drag off this executable node here, drag it, and then drop it anywhere in the event graph. This is going to open up this small window here to prompt you to select an executable action. This means an action that you want to execute or that you want to happen. So you can specify what you want to happen when the play button is pressed. You could do a lot of things here. Of course, you could spawn a player, you could spawn a new level, you could procedurally generate a level, etc. Let's start off simple just by printing out a string or a piece of text. That's what a string is. So here I'm going to call print string. I'm searching for this function print string. And I get this prompt to select a function print string. And you can see this little icon F is hinting to me that this is a function that I'm selecting. So press enter and that is going to select the print string function. Okay, and you'll notice here the two are connected via this white executable node. This executable node means that we're following a flow. We're going to have this event listener, and whenever this listener is triggered, whenever it hears this event happen, whenever this event occurs, we're going to follow this flow and perform whatever actions are part of the flow. And you can keep on adding more flows on and on. Okay, just keep adding nodes. All right, you could also have more than one action immediately happen. In this case, we just have this one action or function called print string. Okay, this is a pre-built function. We didn't make this ourselves. This is pre-built by Unreal. You could also make your own functions. If you made your own functions, they would appear here under the functions list for this blueprint. But because print string is an Unreal function, that's why it doesn't appear here in this list. Okay, a function is a way to store a task so that way you can quickly just reference the function as a way to reference a task that you want to perform. For example, instead of having to manually print out the string every time I want that to happen, I just call the function to do it for me. Okay, so that is this function. Notice that all of the nodes are color coordinated. The events are red, the functions are blue. Okay, and you'll notice this print string function has some properties to it, and I can expand it to see actually even more properties. Okay, so first we have in string. If you hover over any of the properties, you'll get a hint as to what is actually going on here. So Unreal is quite helpful in this way. For example, in string, this refers to the string to log out. To log something means to print it out. All right, so this refers to what we want to print. By default, this says hello, but you can change this. You could change this to say the play button was pressed, because this function is only going to run when the play button was pressed in the editor. Okay, as well, you can select whether or not you want to print the string to the screen and whether or not you want to print the string to the log, which refers to the console. So you can go to the window and you can pop open the console window if you're outside of the blueprint. Okay, if I'm just in my level and I go to window, then here I can select my message log, my output log, or my device output log. Okay, if I want to see messages that are logged to a console. Otherwise, the string will also be logged right in the game, just on the top left-hand corner. So you can choose whether you want to see the string on the screen or in the log. You can also change the text color of the string just with this color picker. Okay, so I could change it to orange. And the duration refers to how long you want the string to appear on the screen. So you have these different properties of the function that you can set. These are known as parameters because you're passing them to the function, and the function is going to use them to do its task. In this case, the task is to print a string. You'll also notice here we have development only in construction like tape at the bottom. This is just a warning to you that this node is only executed in development builds or in the Unreal editor. If you're shipping or testing your project for actual deployment, this function won't run. The reason that this function is just printing a string, it's not actually building any game functionality. So that is why it's development only. All right, if you wanted to actually show some text in the game, you could use a text node for that, but this is slightly different. This is just printing a string for development. And using these print strings, they can be useful to actually help you debug or fix errors, because you can find out what is happening at any point of the game just by printing out some strings. You could pass variables to this string if you wanted to. You don't have to just have text here. Okay, let's go ahead and put this to the test. I'm going to compile and save my blueprint, although that's not required because Unreal will compile it for you when you hit play. But it's useful to compile and save it yourself, just because when you compile your blueprint, if there's some problem with the blueprint, an error message will pop up telling you that. But if I hit play and I had a problem in my blueprint, I would also see the error. Okay, so let's go ahead and test out this game. I'm going to hit play. And look at this. Inside of my viewport, I just saw for 3 seconds that text being printed out. So let me just increase this to 10. All right, let's see, 10 here. Okay, so now I'll see it for 10 seconds. All right, let me just go ahead and press play again. And look at that. I can see the play button was pressed in that top left-hand corner, and it's staying for 10 seconds. All right, I'm also going to just change how my camera is launched by going into the extension of the play and changing it to current camera location, just because I don't want to keep spawning underneath the landscape. I want to spawn above the landscape. There we go. Now I'm spawning above the landscape because I changed my default player start. Okay, and I can see these 2 strings being printed. You may be wondering, why were 2 strings printed? I only said that this function should be called one time when the game begins. Well, the reason there are 2 strings being printed is because we have 2 instances of the blueprint in the game. We made these 2 objects. We dragged the actor in twice. Okay, so that's why we saw 2 strings, because although we have one blueprint event graph, each of the different instances of that blueprint, which you create just by dragging it and dropping it, that creates an instance of the blueprint. Each of those has its own separate event graph. It looks exactly the same, but it is separate. So that's why we saw the function called twice. If you want to see the function called only once, then just delete one of these actors from your game. This time you only have one actor. And if I hit play, I will see, look at that, my text, the play button was pressed, is only appearing once this time. Because the play button was only pressed once, and I only had one instance of this blueprint in the game. Awesome, and that is how you can use an event in order to perform some action. And in this case, we just created here a print string, but we can perform other events as well, like when our actor overlaps with something, or when our actor, for example, runs the game, and then every frame of the game we can perform something as well. So feel free to play around with these other nodes as well. And there are many other events, okay? These are not the only events. If you right click and you search for event, you can see all of the different events available, okay? So on reset, on hit, on begin cursor over, there are quite a few events that you can listen for. So you can listen for when one of these events happens, and then you can perform a task when that event occurs. All right, so join me coming up in our next lecture. We're going to continue learning how to use Unreal. Hello everyone, and welcome back to our course. In this lecture, we're going to learn how to build a blueprint with a player. So for that, we're going to use the third-person template in a new Unreal project, just so that we have a player already in the game. So launch your Unreal Engine 5 launcher again, and this time select the third-person template from the games. Previously we used a blank project which doesn't have a player, and you could build your own player from scratch, but for the sake of time I'm going to just use the third-person template commonly used, which has a playable character and a camera and movement already enabled. Okay, here select all of the regular project defaults, the blueprints, the starter content. Then give your project a name. I'm going to call this my player project. Then press create, and that is going to launch the Unreal editor. Then I'm going to update the project as recommended. If you press play on this project and click inside of the viewport, you can actually run around with your WASD keys, and you can jump by using the spacebar. To look around the game, just move your mouse. Okay, then I can also run up these stairs and keep rotating around, okay, and just run around and jump around the game. So this is the third-person template of Unreal, a great way to quickly get started with building a project just because it already has a lot of pre-built functionality for you. And if you check out our other Unreal courses, we do actually build out projects like this from scratch, because it's great to build it from scratch because then you can understand all the fundamental workings. But if you want to just quickly prototype a game, the templates are great as well. So there are benefits to using a template and also building your project from scratch with a blank project. Okay, so let's hit escape to exit that, and let's go ahead and test out some blueprints with a player. Okay, so I'm going to click on one of these objects, such as my cube. You can see in the world outliner, it's just a cube mesh. Okay, let's go ahead and open up the blueprint view for this mesh. So for this, I'm going to go into details by opening up my details window 1. Okay, and here, click on this icon that looks like a blueprint, and you'll convert this actor into a reusable blueprint class. You can call it cube_mesh_blueprint and use the default creation method. Its parent can be a static mesh actor. Then hit select. This is going to open up your cube in the game, but the blueprint for it, because we took a regular old cube and we converted it to a blueprint, which means we can now add functionality and properties to this cube. Okay, if you click on the event graph, you can see we have the 3 default events. You can also see those inside of the My Blueprint window. We have event begin play, event actor begin overlap, and event tick. Okay, so what if we wanted to check when our player collided with the cube? Okay, because currently, let's hit play and let's see what happens if I run around and I approach the cube. Okay, I just bonk against it. So that means that there is some kind of collision on the cube, because if there was no collision on the cube or on the player, then my player could just go straight through this cube. Okay, so there clearly is something there. All right, there's some geometry. But let's go ahead and enable checking if we have actually collided with that cube. Because often in the game, you'll have to check for collisions. You'll have to check, did a player collide with an enemy? Did they get hit by a sword? Did they find a target? Did they find food? Did they unlock a secret object? And more. So to do that, we're going to go into the cube mesh blueprint. And in the event graph, we're going to select from my blueprint the event actor begin overlap. All right, and here I can now perform some action when this actor overlaps with something else, such as, for example, my player. So to do that, I'm going to drag a new executable node off of the event. And again, I'm just going to call print string, a simple function. You can perform anything you want upon an event. I'm just doing this to quickly do a test. The string we print can be someone collided with the cube. And again, you can add more properties to this function. You can pass more parameters if you'd like. Let's set the duration to 10. Okay, then I'm just going to save and compile everything and hit play again. Okay, then I'm going to drag my viewport a little bit larger, and I'm going to run around, and this time I'm going to touch the cube. Okay, you'll notice here, by default, when I run into the cube, I don't actually have anything happening. No string is being printed. The reason being that we have to make sure that there's actually a collider on my cube and that collisions are enabled. So let's escape and let's go into our cube mesh blueprint. Okay, here we can go into our viewport and we have our cube. We can add a new component to this cube. Okay, let's add in a new collider. So let's search for a collider and let's select box collision. Okay, here we now have box collider. You can select the collider and then let's just scale it to make sure it's an appropriate size. The collider should be the same size as the cube. Otherwise, the collisions won't be processed properly. You could even have the collider be a bit larger just to make it a bit easier for your player. Okay, now let's test this out. Now that we have a collider on our object, we're going to run onto the cube and touch it, but still, oh, look at that. Now we have someone collided with the cube. Okay, so now every time I run into the cube, I see that string being logged. Okay, we can show the string for a little bit shorter of a time. Instead of 10 seconds, let's just show it for 1 second. Okay, and let's go back and press play again. Just make the viewport a little bit larger and press play. Okay, now I'm going to run back at that cube and look at that. Every time I touch it, I get that message printed. Someone collided with the cube. Okay, sometimes you may look like you haven't touched it, so just be sure you've actually touched it. Okay, so in this lecture we learned that if you want collisions to actually work, your object has to have a collider on it. Okay, otherwise collisions won't be processed by default on just any old geometry. Okay, the reason being that collision checking can be expensive, so typically you want to reduce collisions, not check for collisions where you don't have to. All right, there we go. So that is how we can check for collisions between a player and another object thanks to blueprints. You'll notice here the player itself also has a collider. That's why the player here, they have this capsule around them. That capsule is not just for show. Everything inside of the editor has been carefully selected to try to convey to you what a visual represents or what properties an object has. So the reason that this player has this capsule around them is because that is their collider. So it means the player has a collider attached to it, a capsule collider, but other objects by default won't necessarily have a collider attached to them. As we learned with a cube mesh didn't have a collider attached to it by default. We had to add that. All right, and that is how you can build a blueprint with a player in order to process collision events. Quite a valuable task to learn because otherwise you may be wondering why your collisions aren't being processed and you can get a headache, but now you know. You have to have collisions enabled in order for them to work. And collisions are a huge part of games because often you have to check, is something colliding with another? Now you don't need collisions to actually just run around because objects do have a geometry in the space, but you do have to add colliders if you want to process some kind of event, like you want to trigger an event when a collision has been made. All right, join me coming up in our next lecture. We will continue learning how to use Unreal.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.